So once again, the home plate for tonight, it was 4 questions. In your own words, define zero pairs and additive inverse property. In your own words, define the identity property of addition. Represent zero pair using tiles and describe in your own words. Represent -7 and 12 using tiles and zero pairs. Describe your number in your own words. We're going to cover all that in this lesson. I just wanted to give you this up front so you can have it. And this is going to be for home plate for tonight. So with that said, our standard, we're still looking at all operations for rational numbers. And quick intro, let's see. For the last 2 days, we've seen, I did an introduction with a video, right? In that video, I mentioned zero pairs, is that correct? But I also mentioned a property. So this is another way that it could be this situation which I showed you in the video when I was planting my rosemary bush, could be put like this. If I dig a hole 7 feet deep, how much dirt do I need to cover the hole? Does that make sense? Pretty much what I did in the video, right? So I said, when we start with a flat surface, it's called ground zero. There is a flat surface. And then from there in the video, I came up and there's me with muscles. And then here's the hole. And that's 7 feet, right? And the dirt that I dig out, I said I'm going to put it over here. And that's also 7 feet. But to distinguish one from the other, this 7 feet has no dirt. And what does the word no represent? A negative. That is correct. And this 7 feet is yes dirt, which means the yes represents a positive. And that's how we wrote our example, -7 and +7, and that is equal to 0. Is that correct? And we call that zero pairs. Okay? So our objective for today, I can define and represent integers using integer tiles and zero pairs. Let's read it together. 1, 2, 3. I can define and represent integers using integer tiles and zero pairs. Let's read it again. 1, 2, 3. All right. So copy that at the bottom left of your Cornell notes. Write that in your where it says objective. Copy that. And for those of you that already have your colored pens, make sure you're color coding your objective. So, question on the objective. What is the concept for today? By looking at the objective, tell your neighbor what the concept or the main idea for today is. I heard integers and zero pairs. That is correct. But didn't we cover already zero pairs? So what are we going to focus on today? Integers. So therefore, look in your Cornell notes. In your Cornell notes, you have this diagram. Do you guys see it? This is the Freyer model. So inside of here in green, you're going to write integers. So what is going to be the title for your notes? Integers. So write that at the title and write it in your Freyer model. Okay. Now for the definition you're going to write it in black and blue. Here it goes. Definition. Integers are whole numbers including their opposites. 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 Tell your neighbor the definition for integers. Now, you guys already know this? My goodness. So, pens down or writing utensils down. I'll let you finish it off in a little bit. Look up to the screen. I'm going to go ahead and go over the definition. Now, in the past, I know in your other classes, they gave you definitions, you wrote them down, but you were only focused, think about it, you only focused on the examples that they gave you, and you did the same thing for other examples. Is that right? But now, when we get to algebra, I want you guys to actually understand the definitions and the parts of the definition. So check this out. I'm going to go over the definition. It says here, integers are whole numbers including their opposites. So it has two parts here. The first part is whole numbers. So your pencils down, pens down, and you're just paying attention. Here it goes. So what are whole numbers? Let me show you here. In the example, I'm going to draw my number line. Whole numbers are 0 and including counting numbers. What are counting numbers? Well, let me take you back to kindergarten. You're running down the yard. You're trying to beat everybody to the swings, right? And then you tell your whoever's there, I'll race you. Remember that? Got on the swing. And you started counting. Ready? -1. No. We didn't count with negative ones, right? We counted with what? 1, 2, 3, and so on and so forth. Those are my counting numbers. But counting numbers, including 0, are what? Whole numbers. Are we there so far? But what is the last part? They're opposites. So what are the opposites of 1? -1 of 2, -2 of 3, -3, and so on all the way to negative infinity. Therefore, all of these are integers. Once again, counting numbers, including 0, they're whole numbers, but including their opposites, all of them are called integers. Pretty clear? Copy that, please, in your example box. All right. So now that we know our definition, we said integers are whole numbers. What are whole numbers? 0 and counting numbers, right? Including their opposites, yes. So if I gave you this number, is 12 an integer? Yes, because it can go anywhere in here, right? How about 155? How about -28? And how about -267? Yes, all of those are integers, so copy those. And I want you to write your own example. Write your own number in there somewhere. Okay? I hope it's an integer. Right? Because what if somebody's favorite number is a decimal or something? That'll be funny. In the basketball team, there goes .33. No? All right. So, questions, comments with integers. We're good, right? Up to right there? So now let me give you some non-examples. Non-example. Think about it. Pens down, eyes up here. Here it goes. You'll finish copying in a little bit. Look at the non-examples. Okay? These are not integers. So as you're copying this down, think about it. As you're copying this down, think about it. Why are these not integers? Yeah, I said think about it. Copy them down, and you're thinking, why are these not integers? And then we'll share. Copy that, please. All right. So we know why these are integers. So I said you were writing this down and you were thinking, why are these not integers? So share with your neighbor, why are these not integers, please? Okay? So, now that we know that these are not integers, why they're not integers, now let's focus back on integers. What would be the most important thing, one of the most important things to remember about integers? Yes? Whole numbers. Write that in here. That's a critical attribute. Whole numbers. And in parentheses, what would you clarify just to let everybody know what are whole numbers? That they are what? They are not what? Exactly. No fractions or decimals. And what else is important about integers? And their opposites. So make sure it goes here. Those two pieces have to be there because that's what makes an integer. Whole numbers and opposites. And notice right now we haven't really gotten started to do anything except clarify what the main idea is, right? Okay, now that we know, now that we're clear as to what we're talking about, so now let's go to an example. But really quick, I'm going to recap on the properties that we've covered so far. So, first property that we covered in the video, I mentioned this is called additive inverse property. You're just paying attention for this part. You're not writing anything down. And I said the additive inverse property is a number and its opposite that add up to give 0. How does that look with algebra? A plus negative A equal to 0. And with numbers, I introduced it like this. 7 plus negative 7 equal to 0. Remember that? With other numbers, negative 15 plus 15 equal to 0. Or 0 equals to negative 2500 plus 2500. Right? And what did I say? Instead of calling them additive inverse property, what did I call these? Everyone. 0 pairs. So, remember when I talk about 0 pairs, what property is it? Additive inverse property. Does that make sense? Okay, the second property that we're going to work with today is this one. It's called the identity property of addition. Identity property of addition. How does that look? Now, look at these words. Some of you in the past, once again, you just wrote down stuff. You didn't really pay attention to what it meant. Do we know what the word addition means? Yes. Do we know what property is? Well, we've learned in math that properties are kind of like rules. Is that correct? And do we know what identity is? Yeah. Now, when they ask you for an ID, that's an identity, right? You have your name, your student ID, and it usually has a picture, doesn't it? So check this out. This kind of works the same way. The definition should say the sum of 0 and any number is a number itself. That's the identity property of addition. You're just paying attention. An easy way to remember this, guys, is like this. Watch. First of all, addition. Do you see addition here? Yes, it's right here. And then here, the identity property uses the number 0. The 0 becomes kind of like a mirror. What happens when you look in the mirror in the other side? Have you guys ever tripped out on that? When you look in the mirror, that you see yourself over there and sometimes you kind of like go touch the mirror? Oh, don't tell me you've never done that. Come on. So anyways, let's see. Here's A looking in the mirror, and what's on the other side? A. It's identical. You guys see that? It's identical. That's why this is called the identity property. Let's see it with numbers. Let's see if it works. 7 is looking in the mirror. What do you see on the other side? Is it identical? Yes, that's why it's called the identity property of addition. Does it work with negatives? Yes, negative 10 plus 0. What is negative 10 seeing on the other side? Negative 10, and so on and so forth. Does that make sense? And we're going to see that property at work today. Okay? So with that said, underneath the Frayer model, copy this example down, please. You have about 7 lines underneath that Frayer model, right? Copy example 1, and it says, show a 0 pair using algebra tiles, negative 7 plus 7. Copy that, and then I'll show you what to do next. Okay, now that you copied this, we're going to do this one together. So now I'm going to switch to the camera so you guys can see exactly what I want you to do with the tiles. Okay? So, it says, show a 0 pair using algebra tiles, negative 7 plus 7. So what is the first number that we need to represent? Negative 7. So get 7 negatives in front of you. 1, 2, 3, 4, 5, 6, 7. So do as I do, please. Nice and straight like mine. Be nice. What is the second number that we need to represent? Positive 7. So check this out. I want you to do this. Put them right underneath the other tiles. So 1, 2, 3, 4, 5, 6, 7. Okay, so do you have that in front of you? Okay, so now that you have that in front of you, I want you to draw this on underneath the example that you just wrote. So let me show you how it should look on the example. On the example, it should look like this. We start with 7 negatives, 1, 2, 3, 4, 5, 6, 7, and then 7 positives. Okay, copy that. Okay, so now, what do we know about zero pairs? That this is equal to what? 0. Now, this is representing this, exactly the same, but this is to show you with a visual how it's made 0. These 7 negatives cancel these 7 positives, so that means I'm going to circle these together, and that makes it 1 0 pair, and I cross it out because that is a value of 0. Does that make sense? Fairly easy? Yeah, right? Any questions on what you're going to do? Because you're going to do one right now by yourself. So example 2, you don't need to copy the instructions anymore. It's the same instructions. So clear your desk from those tiles, and then I want you to do example number 2. Example number 2 reads, show a zero pair using algebra tiles negative 3 plus 3. So put those tiles in front of you. Then from there you're going to draw the picture here, and cancel out any zero pairs. Copy that. Go. Alright, so your picture should look like this. 1, 2, 3, 1, 2, 3. You circle this, and that is equal to 0. Hands if you got that. Okay, so next, you're going to do this next one by yourself. Last one of these. Copy this. Example 3, negative 10 plus 10. So hopefully by now you already understand the process that we're using. Copy that, do that one by yourself, and then we'll share. Okay, so this was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we circle this together because it's a zero pair, and you wrote equal to 0. So far so good? Alright, so let's see. All 3 examples that we've seen, they represent what? This represents 0. This represents 0. And this represents 0. Are we there so far? Okay, now here comes a challenge one. So I'm going to crank it up a notch. Okay? Example 4. You might not have room there, so turn your paper over. And in the back, copy this example. Example 4. Write this down. Example 4. Represent negative 1 using algebra tiles and 0 pairs. Represent negative 1 using algebra tiles and 0 pairs. Write that down. Represent negative 1 using algebra tiles and 0 pairs. Copy that. So if I was to do this one with you and I was to show you my tiles, check this out. To represent negative 1 using algebra tiles and 0 pairs, I would do this. This is me. I need a 0 pair. Then that means I would do maybe something like this. But this represents what? 0. But what are they asking me to represent? So that means I just need to add a negative. Does this represent negative 1? Yes, because I can circle my 0 pair, and this is negative 1. So now you write your own example of a negative 1. This is my example, using 0 pairs and integer tiles. Then I'll use a randomizer to call on somebody to give me their example. Three negatives and 2 positives. You circle your 0 pair, and that represents negative 1. Does everybody agree with that? Yes? Pass it to someone. One more example. Bailey? Four negatives, 3 positives. Circle this 0 pair, and that represents negative 1. Does everybody agree with that? Alright. Did everybody get the idea now? Okay. Example number 5. Do this one by yourself. See if now you can do this one by yourself now that we did one together. It says represent 4 using algebra tiles and 0 pairs. You don't have to write the whole thing. Just write example 5, represent 4 positives. And we already know that the instructions are using algebra tiles and 0 pairs. So now I want positive 4. Again, copy that and do that by yourself. Go. 6 positives, 2 negatives. 1, 2, 3, 4, 5, 6. 2 negatives. Circle this. And we're left with positive 4. Does everybody agree? Okay, pass it to someone. One more example. Who? Who? Natalia. Three negatives and 7 positives. 4, 5, 6, 7. Does that represent 4? Yes, right? Okay. Let's do one more of these. And once again, see if you can go a little bit faster without using your tiles now, but just draw me the picture. Number 6, represent negative 6 using algebra tiles and 0 pairs. Okay? Check with the neighbor, see if you have something similar to yours. Alright? Let's see. Melanie, can you give us your example? Negative 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 12. 1, 2, 3, 4, 5, 6. See, 2, 4, 6, 8, 10. Oh, I'm missing 2. Okay, there it is. So this is a 0 pair, and we're left with negative 6. Does everybody agree with that? Yeah, pass it to someone. Victor? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4 positives, 0 pair, and we're left with negative 6. Everybody agree with that? Yeah, right? Sorry, I forgot to circle that. So now check this out. What we just did, we were adding and subtracting positive and negative numbers just using those properties that we just covered. Did you guys see that? Pretty cool, right? Now watch. If we go back with this one, look, what is my negative number here? Negative 2. What's my positive number? 1. So what is negative 2 plus 1? Negative 1. Let me show you this one. What is my negative number? Negative 3. What's my positive number? 2. Does that represent negative 1? Yes. Look at this one. Negative 4 plus 3, and that is negative 1. Let me go to the next example. Look at this one. What is my negative number? Negative 2. What's my positive? 6. Does that represent 4? Yes. Negative 3 plus 7, and that represents 4. And the last one. What was this one? Negative 12 plus 6, and that is negative 6. And this one is negative 10 plus 4, that's negative 6. Isn't that cool? Pretty good, right? So, now that we have that idea by ourselves, copy this one. This is going to be one of the last ones. Example number 7 says, show me negative 6 plus 9 using algebra tiles and 0 pairs. But for this one, answer the questions. What does it represent and why? Think about that why. How would you explain it? Copy that. See if you can do that by yourself. Go. It represents 3. Okay. Why? 6 negatives take away 6 positives. They cancel. That makes a 0 pair, and that leaves us with what? 3 positives. Does that make sense? Yeah, and representation will be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. Hold on. Let me finish this up. So, did we cover the additive inverse property? Yes. And do we cover the identity property of addition? Yes, those two. For today's home play, you're going to be answering some questions in regards to those. Okay? All right, guys. Have a good one, guys. Enjoy your home play. I'll see you guys tomorrow. Put my tiles back in the baggies, please.